See this. For what values of lambda will the following equations fail to have unique solution? So it's very interesting question. So concentrate here. Not very easy to understand. Let's analyze it. Okay. So now what they are trying to say is for what values of lambda. So lambda are given here. So lambda is here and here. It is just the system of equations as we have seen earlier. Now what should be the values of lambda for which this system will fail to have unique solution? So in order to understand that, let's see when the system will have unique solutions and then let's try to fail those conditions so that it will not have unique solution. Okay, I'll go step by step. It will be a bit difficult to understand, but try to focus here. Now that is first question, and then there is a continuation. We shall see this question as well. First of all, write this in terms of matrix equations. Ax equal to b, or if you want to write, you can write them as ab, and then you can proceed. I'm just following it. Okay. Now the next step is convert it into some other form so that finding out the determinant will be easy. I prefer echelon form. You need not go till the end of echelon form, but you can convert it to some extent so that finding the determinant will be easy. Now using this element, I want to make these two elements as zeros just to find the determinant easily, but then having a 3 here and 1 and 2 here is a bit difficult to handle. That is why I try to move this one here and this 3 here. For that reason I'll be exchanging R1 and R3. Then I got 1 here, right? And now using this one, I want to make these two as zeros. For that reason I am just multiplying R2 with 2 and subtracting from R2 and replacing it there. The same conditions, the same kind of transformations which you have seen earlier. You know how to make them as zeros, right? And I did that. I made them as zeros. Then finally I got this form. So in this form it will be easier for me to find out the determinant of this matrix. That is why I am going to stop it there. Now see this condition for unique solution, which means if we are supposed to have a unique solution, then what is the condition we should follow is rank of A should be equal to rank of AB should be equal to n, where n is number of unknowns, isn't it? So if rank of A is equal to 3 and rank of AB is equal to 3 and this number of unknowns is already 3, rank of this one is 3, and if rank of this one is 3 and if this one is also 3, it is already given, then it will have unique condition, unique solution. Now what is that in our hands is, what is there in our hands is this rank of A. We can fail this condition by just doing a small thing. What do you think? We can make it not 3, we can make it 2. If I can make rank of A as 2, right, then what happens is rank of A will be equal to, it will not be equal to rank of AB, will not be equal to rank of number of variables. See, this one I'll make it as 2, I'll try to make it as 2 or less than 3, and this one I don't care. Once I make it as 2, definitely this equation fails because here it is already 3. I hope you are getting this. I need not worry about AB, I will just worry about A. Now for this condition to fail, for this condition to fail, what should happen? Rank of A should not be 3. If rank of A should not be 3, then what do you think about determinant of A? A is a 3 by 3 matrix. If its rank should not be 3, then the determinant of A should be 0. Try to follow it. See, A is a 3 by 3 matrix. Simple. A is a 3 by 3 matrix and I want its rank not to be equal to 3. Then what should happen? Every 3 by 3 square submatrix of A should have determinant as 0, isn't it? Therefore what can you derive from this? Simple topic, understand it. A is a 3 by 3 matrix, its rank should not be equal to 3. Then from this condition it is definitely true that determinant of A should be equal to 0. When determinant of A equal to 0, it means that rank cannot be 3, rank will be less than 3. That is what I wanted. Okay. Therefore for this condition to fail, determinant has to be 0. So what can we say from that condition? If this condition holds, If determinant of A becomes 0, we can say that definitely rank of A is less than 3. Definitely this condition fails. Definitely there will be no unique solution. Now I'll try to find out the determinant of this. Just see this determinant of this, we can directly derive it. Right? Determinant of this one is nothing but determinant of these 4 elements. And if I write it in form of equation, I got this. So determinant of A should be equal to 0. What does it mean? Lambda should be equal to minus 7 by 2. Therefore, for lambda equal to minus 7 by 2, it will not have unique solution. Now, whenever we don't have unique solution, there are two cases, right? One case is, yes, you need not have unique solution, but then if it fails, unique solution fails, then there are two other cases. Totally there are three cases if you remember, right? So one case is no solution at all, and the other case is infinite number of solutions. Now we are able to say that there will be no solution, no unique solution if lambda equal to minus 7 by 2. That is what we are able to say till now. But then what happens if it is having no solution at all and infinite number of solutions? That one we should derive. Now say this. When will there be no solution at all? There will be no solution if this is 2 and if it is not equal to rank of AB, which means if rank of AB happens to be 3 and if this one happens to be 2, then there will be no solution, right? And when there will be infinite number of solutions, if this one is 2 as well as this one is 2, which means it need not be 2, if this one is something and this one is the same thing and both are less than 3, then there will be infinite number of solutions. Now the second question is, will the equation have any solution for these values of lambda? You are saying that for the value of minus 7 by 2, there is no unique solution. But is it true that there will be no solutions, or will there be infinite number of solutions? That is what we wanted to analyze. Now what we are trying to do is, let us substitute lambda equal to minus 7 by 2 in given equations. If I put lambda equal to minus 7 by 2, I got this. And now by applying modifications, some transformations here, I got this one. So now observe this. This is A, and when I combine with this one, it is going to be AB. Now it is very clear that in A, the number of non-zero rows are 2. Therefore, rank of A is 2. And in AB, the number of non-zero rows are 3. Therefore, rank of AB is 3. Rank of A is not equal to rank of AB. Therefore, we can say that there is no solution, which means the system is inconsistent. So it is a bit difficult to understand right away unless you understand how to analyze these conditions. If you can understand this part, everything else is straightforward. So let me tell you one last time. First of all, they are asking us that these three equations should not have a unique solution. Then what are the cases that we have to form, or what are the values of lambda? For that reason, I have written this condition. If this condition fails, then it will not have unique solution. If this condition has to fail, already n is 3, which is fixed. You have to make this one or this one not equal to 3. But then rank of AB is not in our hands. Rank of A is definitely in our hands because this is the part which is involving lambda. Therefore, I am trying to make it not equal to 3. For that reason, if rank of A, which is a 3 by 3 matrix, should not be equal to 3, then it should definitely be less than 3. It implies that determinant of A should be equal to 0. Yes, determinant of A should be equal to 0. Then only it will not have unique solution. I found out for what value of lambda it will not have unique solution. But then, if it is not having unique solution, then it means that it falls in two other cases, either of the two cases. What are they? One is it will have 0 number of solutions, which means no solution. Other is infinite number of solutions. Next question is about analyze which one it is falling in. Therefore, I am going to substitute lambda equal to minus 7 by 2 and then analyze it. Then in that case, I got that lambda, the rank of A is not equal to rank of AB. You can check this. Even though I have written it in this form, you can just merge them. This is A, this is B, and you check them like earlier examples. Rank of A is going to be 2, rank of AB is going to be 3, which means the system is inconsistent. Why inconsistent? You can check this. The third equation, if you multiply the third row with this column, and equate it to this, you will get 0 equal to minus 16 by 3, which means inconsistent. Therefore, in that case, will not have any solution. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.